So delegates, I wanted to talk about delegates. It's just I'm going over all the the framework constructs in my own mind, and just trying to stay fresh with everything, and made me think that it might be worthwhile explaining it to everybody, and it will help me just to teach it. So thank you for coming, and yeah, bear with me in case I get anything wrong. But if you have any questions, stop me. The reason I have an interface up is for me, delegates are. It's easy to think of delegates how they work. It's kind of like an interface. Right. So, everyone's used interfaces themselves. We write an interface and we say, you got to have this method or that method if you want to call yourself a standard interface. So you guys know how it works. If I wanted to call myself an interface, I would have to employ everything the interface said. It's a contract. It's saying, hey, if you're going to call yourself this, you have to do these things. Well, a delegate is very much like that. Where you declare, you use the delegate keyword. After that, you're declaring what a method. So a delegate is an interface for methods, is how I like to think of it. So basically you're saying, hey, if you're going to call yourself this delegate, you've got to return this, and you've got to take in that. If a method has this signature, then it can call itself a print, which print becomes an actual type of delegate. And when you're able to do that, and again, this comes all the way from C# 1.0. This is something they added into the language, and because it's very helpful. When you do that, you're able to parameterize code, and I'll show you what that means in a minute here down the line. But let's just keep moving. So you can see that these two methods, print number and print money, both satisfy the needs of the print delegate. They have void, and they are taking in one in, and it's the right type. But the cool thing is they do different things inside, but they're still of the print delegate. I'm sorry if this is too basic for some of you guys. I'm going with as basic as possible, and we're going to build up, and yeah. So anyway, this one will not work, right? Because it takes an int. This is a bad method. You cannot declare this method as a print delegate. All right, so parameterized code. Sounds kind of weird, but all that means is that you can now, inside a parameter list for a method, is you can send in a delegate, because this is a type. So the print type, which is like sending in an int or a string or a bool, but now we're sending in a delegate. And what's encapsulated inside of this is actual code that's doing who knows what. So the reason one of the main reasons you have delegates is when you have an algorithm that you want to do, you want to do certain things inside of a method, but there's all kinds of, you have similar implementations in different methods that do a lot of the same stuff, but just things that are slightly different. But the final outcome is, maybe you want to log to a file. You don't care, or you just want to log. You don't care where it logs to. You just want to log. Well, delegates allow you to do all kind, this kind of thing where I don't care what you're doing inside of your method. Do whatever you want. This print helper is just going to call it. This is really kind of simplistic example, because all it does is call the actual method, but it does combine it with the actual number to print. So here it's actually calling whatever method it is, and it gives you the number to print. We'll run this here in a second, and I'll show you how that works. So if I'm getting ahead or you're confused, just hang on or stop me, and we'll go with it. So let's just define a couple more delegates. So I'm going to define one called funky, which is not a generic. So we have generic delegates as well. It was C# 2.0 where we were able to, or where they introduced generics, which made our delegates get a little cooler, because now we can do something like this, where we don't care on the delegate what type it is. You just, you declare it's a delegate, and you provide what generic types you want to use and how you want to use them. So here I define a delegate that is not a generic, just kind of like the one we did above. We take two ins and one out. Here we have a generic delegate that two ins, one out, but you can see here that with this generic delegate, the second input parameter and the output have to be the same. If you have a method that doesn't follow this style, it can't call itself funky generic. Does that make sense? I hope. I'll show you an example in a minute if it doesn't. I call this funky generic func, and I'll show you the reason why. You've been using, you use delegates all the time if you code in C#, pretty much anywhere. You may not realize you've been using them, but we'll go over the different types of delegates that are built into the framework here in a second. This one takes in 3. Well, yeah. So this one takes in 3, and the difference is the first the output does not have to match the second one. So this is a little bit more flexible. If you don't want it to be flexible, you have you want to write it this way. So
Tom, what do you mean there by not having to match the output as far as the O type?
Well, yeah. So in a generic, we say, hey, I want 3 things. If you're going to make this generic, you need to make 3 things. This could be anything that the person wants. It's generic. But you can see is I name them T, S, and O. O is on my output, where S I'm listing as my second.
Gotcha.
So this could be an int. This could be a bool because these are separated. Here we're using the same O for both of these, so it has to be the same type. Yep. So the interesting thing is this one method here satisfies all 3 of those delegates above. And let's just see how. Well, int for funky takes a string, takes an int. For the generic, it has 2. And yeah, with string, int, and you can see the int is the same. So this matches number 2. And number 3, it's fine too, because again, remember, number 3 is more flexible because this could be anything. It doesn't have to match this second one. All right, so let's step through and show you how it works. So print helper is a function that takes in the delegate, if you remember that, right? We're going to pass in print number, which we can pass in print number because remember, it's needing a print delegate, and print number satisfies what print is asking for. Print money does as well. So you can see here when I go to call print helper and it says I want a delegate that's a print, you can say, oh well, shoot, print money does what print wants. So does print number. So we can send in both of these different types of code and do 2 different things. Let's just run it and show you. So you'll notice it's asking for the delegate. It's asking for a delegate function, right? Let's see what's on here. I don't even print. No. Oh yeah. So you can see here's the name of it. This is the one that's sending, or that it's called. You can get, it's actually that deal because it satisfied it, and it's going to call it. It's going to call there just like you would expect, and then print helper does the same thing. It calls print money, and that's pretty simple. And let's check. So we should get 2 different things. We called the same method twice, got 2 different result sets because we parameterized code. Very, very cool. Now, but what I couldn't do, and this helps clarify things, I can't say print helper won't work. Red squigglies. It's going to be like, boy, there ain't no over, cannot convert from method. Yeah. So it can't convert the method to a print because won't work, won't satisfy it because why? You guys remember?
Doesn't match the delegate.
Right. It doesn't
match the signature. Yep.
Yep. It doesn't void, and it doesn't send in the right deal. If I go here and say int, you'll see those red squigglies are now gone. Now it matches. It's like, all right, go ahead. But okay, moving on. This freaking lint thing has got me all screwed up, or style cop. Like you'll find some of the time I make a space now because because my brain is I have to make a space after comments, but I didn't ever do that before. So if you notice my commenting, you'll see it's pretty sporadic as I remember. All right, so now let's call the generics, right? So you guys remember that we said that my funky version satisfied all three of these, the one that's not a generic and the two. Let's just prove that. Here's how you can declare an actual delegate. You can say funky because it's a type, my funky, and equals my funky version because this satisfies it. Do it the same way here. My funky generic is equal my, see, it's my funky version and my funky version. This method, as I said, can be all three of these generics. My funky generic function, because this actually works because I'm in my generics, David, as you were asking on the O and the S, only because I declare my generics with the exact right types that it allows this thing to work. If I was like, no, I want this to be, I want the second variable to be an int, but I want the output to be a bool. Well, you know, this matches what the parameters are doing for my funky version, but my funky version is returning an int. So it's like, nah, you can't call yourself that, bruh. You're not really one of those.
So the delegate doesn't necessarily care, you know, that you change it to a bool or anything. It's just that that function didn't implement that same signature.
Right. When you do generics, it's I mean, delegates are already super powerful in what they can do, and then if you add the power of generics on top of it, it's kind of mind blowing. Yeah, because we have this crazy delegate that can take in code, but then when we add generics so that you declare the types when you're declaring the delegate, it's pretty powerful.